Good morning. Hope you guys had a nice weekend. So we had tests last week, and we'll go over that shortly here. And for tomorrow, there's not a new lecture video. We'll just continue chapter 23, just working on problems. There's a section in somewhere on Moodle. I'll have to check. I think it might be under the problem sets or under lecture videos. There's a bonus problems for amines. So there'll just be a couple of extra problems that we'll do for the amine chapter. And if you could, I would like you to watch the Total Synthesis Project Introduction. It's in the Lab tab for Moodle. So you can kind of get an idea of what you're going to be looking at for your project. Your molecules that are assigned to you are also, or can be found on Moodle in the Lab tab as well. And then if you have questions about the project, you can bring those tomorrow. And the retrosynthesis for your molecule will be due on Friday. So that gives me an opportunity over the weekend to see if you have any pitfalls with your total synthesis, and then we can address those. And if you want to turn it in earlier, you can. If you have questions or want to send in any analysis beforehand and want me to look those over, I can do that as well. So your week 4 homework is due today. If you haven't already turned them in, if you did, I think the ones that are here right now already turned them in. They've been graded. Those are there. Lab 8 aldol reactions is due tomorrow, and then your week 5 homework, which is your last homework for the summer, will be due next week. So there's no homework that is due next, or that will be assigned next week. So week 5 homework is the last one. And then again, your retrosynthesis for your total synthesis molecule is due to Moodle on the 25th. And then Thursday, Friday, we have quiz 3 questions yet. All right, so let's take a look at the exam. I think both of you took the exam earlier, so the answers might look a little bit different. There was some miscounting that I did on the questions, maybe depending on which version you had, 1 or 3. There's definitely error on 3, so those I think listed all as 4 prior when you were taking your exam. So if you were pretty close, then you got credit for that. And for question number 1, if you did the version on the left, then that one was fine. The one on the right was the one that was incorrect. And then those are the answers there. Questions on the first page that you might have. And you'll be able to find the answer keys on Moodle already. Okay, no questions on the first page. And then here is the second page. Number 8 seemed to be problematic for ranking of acids from least acidic to most acidic. And you either, some of you answered with D in the wrong order, and the D has D, or I shouldn't say D because some of you had C. But this alcohol on the benzene ring has the opposite effect of a fluorine. It's actually going to donate electrons in, so that will make it less acidic than the one without the OH group there. So that one is less acidic than the one without it because it's going to have the opposite effect of the fluorine. And then otherwise, I think the rest of you did okay on this page. Questions on this page? All right, and here is the next page. So these reactions are similar in both. Of the ones, the few that are here did okay, I think, on the arrow pushing mechanism, but you do want to be sure on mechanism questions to draw all those arrows and intermediates in. And then we have for 12A on both of these, there should be a rearrangement there with that alkyl group that's being added. So you should have a secondary group there. And then the rest of the problems, I think, for you guys seem to be okay. Any questions on this page? And here's the next one. Questions here? The average on the exam, in case you're wondering, was 70. Just around about the same as the last exam average. And then here is the next one. I think you guys did okay on this one. C was, I think, problematic for many of you. The one thing, this is the acetoacetic ester synthesis. So the most acidic proton was this one right here. So a lot of you were adding the alkyl groups to the end carbon over here, but it should have been added to the middle. And then you would do in step 4, the addition to the alpha beta unsaturated carbonyl at the 4 position to get the 1,5 diketone or dicarbonyl. Questions on this one? And then here are different solutions for the synthesis page. So as you're, if you're beginning to start thinking about studying for the final exam, you may want to try doing the synthesis problems that were on either of the exams, or maybe all of them, that you didn't do on the actual exam, and then you can just check your answers to see that. So that would be a good practice, just to start recognizing disconnections, etc. So for practice, if you need synthesis problems to do, just look at the other problems that you didn't do on the exams. All right, well, questions on the synthesis? Or any other exam questions? All right, so we'll start with chapter 23 recap then, or move there next. So amines are classified just like alkyl halides and alcohols. So if you have NH3, that is just ammonia. And then if you have 1 carbon on that nitrogen, that makes it a primary amine. 2 carbons on a nitrogen is a secondary amine, and the R's can be the same or they can be different. And if you have a nitrogen with 3 R groups on there, that is a tertiary amine. Amines can act as acids or bases, so they can donate a proton or they can remove a proton. And that will depend on what else is in solution with it. So a nitrogen in the presence of HCl is going to act as a base and deprotonate that HCl and become a quaternary ammonium salt. This is a quaternary amine. A quaternary ammonium, so that IUM ending tells us we have a charged nitrogen there. And then that makes it more water soluble. Then we have base properties of amines. If you have more alkyl groups on a nitrogen, that's going to make it more basic. Electron donating groups make it more basic, and electron withdrawing groups make it less basic. So an amide versus an amine, this is less basic because of that electron withdrawing carbonyl, and this is more basic. Questions there? So ammonia is going to be less basic compared to tertiary. This is more basic. So the extra electron density from those R groups are making that nitrogen more basic. All right, when we're naming amines, this is very similar to actually when you were naming amides, but we're going to name the alkyl group ending in the YL followed by the word amine. Or you can use amino for the side group if you have multiple functional groups. So this first one here is N-isopropyl, And then the one with the most carbon chains, if you have this tertiary here, the one with the most carbons, this one has 6. That one's going to be the parent. So it's cyclohexyl, and then we end it with amine. But on there we have N-isopropyl and then N-methyl. And that's listed in alphabetical order. So N-isopropyl, N-methyl, cyclohexyl, amine. And in this middle one here, phenol is the parent. So we would list the NH2 as an amino group at the 3 position. So this would be 3-amino phenol. And the last one here, we have a 2-carbon chain versus a 4-carbon chain. So it will be cyclobutylamine and then N-ethyl cyclobutylamine. Questions on nomenclature? All right, amines have high boiling points, but they're not as high as alcohol. And then more hydrogen bonds equals a higher boiling point. So the NH2, the primary amine, has different, let's see, 1, 2, 3 places that it can hydrogen bond. This one only has the 2. So 1 from the lone pair of nitrogen electrons and then the hydrogen. So this is 2 spots for hydrogen bonding, where the primary amine has 3 hydrogen bonding spots. So we have a boiling point of 50 degrees. And the tertiary amines, which don't have any hydrogen bonding capabilities, that one has a very low boiling point. But if you compared it to propanol, I think this boiling point is maybe around 85, something like that. So it's less than an alcohol, but greater than a secondary amine. If you had 2 amines, this has many more spots for hydrogen bonding, so the boiling point for a diamine is going to be higher than just 1 alcohol. Questions there? All right, and then here we can look at ways that we've seen already to make amines. One of them is using an alkyl halide with sodium cyanide, doing an SN2 reaction, and then reducing it with excess lithium aluminum hydride. So this will make an amine, but it also adds a carbon. Or we can make it from an acid chloride or an acid carboxylic acid. After we form the acid chloride, react it with excess ammonia. That makes the amine, which we can reduce to lithium aluminum hydride. And then if you're working with phenols, we can use benzene and then add the nitro group, reduce that with H2 palladium and to get the amine or the aniline here. Or you can also reduce it with iron, zinc, tin or tin chloride, followed by sodium hydroxide in order to get that amine. So these are reactions that we've seen already. So this first one here, this was way back in chapter 8, maybe. That was alkene. So it's probably chapter 7. The lithium aluminum hydride reduction, this was, I think, in the last chapter, or 21. This was chapter 21. This was chapter 10? No, 18. 19. And this was also, these are all chapter 19. So these are not new reactions to us, but we will add new reactions soon. Okay, so look at the structures here. Which of them is representing N-cyclopropyl isobutyl heptylamine? So it'd be N-cyclopropyl. This should be an N here as well. So which of these fits the correct structure here? All right, so we're looking at N-cyclopropyl, which is a 3-membered ring. And then isobutyl has 4 carbons and an iso group at the end. So that's what that one looks like. And then heptylamine has 7 carbons and it's not cyclic. So we're not looking at A here. This would be sec-butyl. This one is an isopropyl because there's only 3 carbons there. So our correct answer here is C. All right, any questions on that one? All right, which of these has the highest boiling point? All right, so A will be the lowest if we were ranking them. And then the tertiary amine is next. This actually goes in order here. So this is the highest boiling point because alcohols, even if it was one alcohol, is going to have the highest boiling point, but here we have 2. So that's definitely the highest. And then this is the trend here. So lowest to highest. Even if you had one NH2, that would be between here. So if you had NH2, that would be between. Questions there? All right, this is a review question, sort of. So what is the product of this reaction? All right, so the Br plus NaCN, if you remember this, is going to add here. And with that CN, we're adding a carbon. So A, which all of you selected, is not adding a carbon. This is not the correct answer here. C would be what you get after the first step, and the lithium aluminum hydride will get us this one. So remember that you're adding that extra carbon there. So that would be the answer there. Questions there? All right, so now we have some reactions to add, and normally I would use the .cam, but for some reason it was not working this morning, so we got to do it on here and hope that I don't have too many computer glitches. So this is on your functional group transformation page, which should be 11 in your reaction book. And the first one we're going to start with is ammonia. And we're going to react that with an alkyl halide. And when you do that, the ammonia is going to attack the alkyl halide and add 1 R group. And then if you remember, every time you add an alkyl group to a nitrogen, that makes it more basic. So that's going to keep reacting until you've added as many R groups as you can add. So you're going to end up with this ammonium salt with the halogen as the counter ion. So ammonia plus an alkyl halide is going to alkylate as many times as possible. So if you wanted to make a primary amine, this would not be the way to do it because it won't react just one time. Instead, the way to make a primary amine, or one of the ways, is to use sodium azide and then follow that with H2. See, I was hoping that wouldn't happen. All right, so we'll start from the second one I had. So N3 is azide. And then we react that with H2, palladium, or you can use lithium aluminum hydride. So the R, or the N3, which is a minus, can form a new bond here. So you would get N3, and then you reduce that, that will form the NH2. So that is one way to make a primary amine. The next way is the Gabriel synthesis. And in this one, you actually start with thalidomide. So your nitrogen source is right there in that ring. And then what you do is take potassium hydroxide, which will remove the hydrogen from that nitrogen. And then you're going to add an alkyl halide so that N- can attack the R group. And it will only do that one time because we have 2 electron withdrawing groups on that nitrogen. So we won't get over alkylation. And then after you add the RX to remove the rest of that stuff that you don't want, we'll add NH2, NH2. Then you have N, H from there. Pick up another hydrogen and our R group. This is the Gabriel synthesis. The next reaction involves, you can use this to make a primary, secondary, or tertiary amine. This uses an aldehyde or a ketone. And then you're going to use an amine. Can be primary, secondary, it could even be ammonia. And then in the same reaction, you're going to add sodium cyanoborohydride. So with this reaction, you're first going to form the imine, like you would normally with the ketone aldehyde plus an amine. So that'll form the imine, and in the same reaction, you'll also reduce it to the amine. So for this, you can use NH3, primary or secondary amine. We have our NH2. In this reaction, you add methyl halide in excess and follow it with silver oxide. And this will do a Hofmann elimination. So that gives you the least substituted alkene. Most of the eliminations that we've seen will give the most substituted. This one gives us the least. So the nitrogen is going to alkylate multiple times till it forms that quaternary amine or ammonium, and then that silver oxide will eliminate to give us the least substituted. Questions there? All right, so the next reaction, this is chapter 23 continued, involves a secondary amine. You add sodium nitrite with HCl, which forms this HONO, or they call it HONO. That will form a nitrosamine. Or an N-nitrosamine. And a lot of these derivatives are formed in situ, so in your body if you're exposed to primary or secondhand smoke, and that is dangerous for your DNA. So that can happen a lot of times when you're exposed to cigarette smoke. All right, so if you do the same reaction with a primary amine, we form the azide. And that azide is a very good leaving group because you're losing N2 or nitrogen. And most often we use these reactions on an aromatic ring. So if you have this aryl ozonium, you can react it with copper with an X here. Oops. And that will just replace the diazonium with whatever the X was. Where X can equal Br, I, Cl, Cn. So if you wanted to add a nitrile to the benzene ring, you can do that very easily. And then you can also use, instead of copper, X, HBF4, if you use that reagent, will allow us to fluorinate. So we didn't have a way before to add fluorine to the benzene ring, but now we do. If you just add water to that reaction, well, I don't know why you would want to do this, but if you added water, that will just add a hydrogen. So you'd get benzene. And then if you added, oops, I'm sorry, that would make it phenol. So that's a different way to make phenol there. And then if you add H3PO2, that will add a hydrogen. So in order to use this diazonium, you have to have aniline present, so the NH2. So it can't be the nitro group. But if you were going to do a synthesis you would start it with the benzene, add the nitro group, reduce it to the amine, and then make the diazonium, followed by copper X. All right, the last reagent that we'll add to this for chapter 23 is using aniline. And if we try to do add Br, nitrogen is an ortho-para director because it's electron donating. But it's also very strong of an electron donator. So what you can do, or what happens, I guess, is you brominate ortho, ortho, and para. So it's going to add that bromine to all of those positions because it is so strongly electron donating, and that benzene ring gets very reactive. So for that bromine reaction, it'll brominate several times over. If you wanted to avoid that overbromination, or if you wanted to do a Friedel-Crafts reaction using aniline, you'd have to acetylate it. So react this with acetic anhydride and make that a C double bond O CH3 coming off of there. So we'll encounter some of those reactions later. Questions on any of these reactions? Okay, what is the product of this reaction? Okay, for this one, this is it's called a reductive amination. And we first react it with, or in the reaction, it will first form the imine. So it would go to C first, but with the presence of the sodium cyanoborohydride, it would then go to A. So this is our correct answer here. Questions there? All right, how about this one? All right, so for this one, the first thing that happens is we'll get methylation. So we get 3 there to form that quaternary, and then we'll do an elimination to give us the least substitute alkene. So we'll get C for that one. All right, any questions there? All right, how about this one? All right, here we're going to replace the azide with the Br. So we're going to get bromobenzene, which was B. Questions there? And what about H3PO2? All right, good. So we're going to get D for this one. The H3PO2 is just going to make benzene again. So that might be something that makes sense if you have multiple things on your ring, but to go through all that trouble to make benzene seems kind of silly. All right, and with water? All right, and this one, water, will give us phenol. Good. All right, name each of these compounds. So how would we name these? Well, when we do the nomenclature here, all of these substituents are on N. We find the parent, which will have the largest number of carbons. So we have methyl, methyl, and then cyclopentane. So this will be a cyclopentylamine. We have two other groups on there. So we would list them as N and dimethylamine. And then if you're doing stereochemistry for this, the parent here is going to be cyclohexanol. The alcohol will take priority over the amine. This would be listed as an amino. Our H is 4, 2. So this would be our, that's the wrong way, so that's S. That one is S. So this would be 3, would be 1S, 3S, 3 amino, cyclohexanol. In case you don't remember stereochemistry things, there will not be any stereochemistry of RS on the final exam. This is just kind of to bring that back a little, in case you're studying for MCATs or something. That could show up on the MCATs. All right. Next problem. Which of these will predominate at physiological pH? So what this question is asking, which you'll probably see more types of questions like this, is in physiological pH is the pH in our bodies, which is at 7.3. So it's asking what is going to be protonated at pH 7.3. So if you're looking at pKa's of different amines, this one is around 40 or 35, something along those lines. So that would be protonated in our bodies. So nasal decongestant phenylpropanolamine, which is very similar to the structure for pseudoephedrine. The nitrogen would get protonated here. And protonating amines, or making them into the salt, will make them more soluble so that we can access them better biologically. Questions there? Okay, so if you were doing this reaction, draw the structure of an alkyl halide or carboxylic acid that you could use in order to make these amines. So what are ways that you could make these primary amines? So take a minute to try to figure out what you can use to make these primary amines, either with an alkyl halide or carboxylic acid. Okay, so if you wanted to use an alkyl halide, so let's say we're using bromine, we definitely do not want to use, let's see, this one plus ammonia. That will not give us our target molecule. What that will do instead is make N with this ammonium. If you want to use the alkyl halide, then we want to go through the CN route. Actually, there's a couple different things that we can do. So if you use with 3 carbons, you can do NaCN and then reduce it with LAH. Or you can use the 4 carbons, use NaN3, and then H2 palladium. And if you're using the carboxylic acid, you can use SOCl2. And then reduce that. Questions there? All right, and then the same thing would work for that last one there. If you wanted to use the carboxylic acid. Or you could use the NaN3. So if you're given any alkyl halide, then you can use, the shorter route, which would be the NaN3. But if you have only a carboxylic acid available, then you'd have to go through this other route here. Questions on that one? Okay, so using the Gabriel synthesis, how would you make each of these? So remember, the Gabriel synthesis involves that thalidomide, or I think it's phthalimide, not thalidomide. This one here, we need KOH, some alkyl halide, followed by NH2NH2. So to find what our alkyl halide is going to be, you want to remember also that this nitrogen right here is this one right here, and the R group is going to be the rest of it. So really you can just take this whole entire thing as the R group. So R in our case equals this diphenyl with a Br there. So that's how you could do that. And then the same thing would work for this one here. We're just going to take everything on the other side of that. R here would equal that compound. So we would take the thalidomide, the KOH would remove that proton. And then you would react it with the R alkyl halide. So you're just doing an attack on that secondary alkyl halide there. Questions there? All right, so we have to show here 2 different ways of preparing each of these via reductive amination. So one of the things that we're going to start with is an aldehyde or a ketone. And so you can pick any side really. So if I just draw a break here, this would be my carbonyl. And then I would react that, if you remember, we can use ammonia, primary or secondary amines. So it will just be the nitrogen here with the methyl, that propyl group with an H there, and then sodium cyanoborohydride. And if I wanted to do a different disconnection, maybe I want to use that. So it would be formaldehyde with the nitrogen, 3 carbons on either side, and NaBH3. Questions on that one? You could also, if the R group was different on the other side, you could use a different one, but because they're both propyl groups there, that would be the same as the first reaction that we did. All right, C is kind of tricky because it is a ring. So if I made my break right there, I would have this carbonyl. So number my carbons. The carbonyl was 1, 2, 3. This is 5, and on 5 there was a nitrogen, and then H2. So we would just have this structure, and then plus NaBH3Cn. And then if you wanted to disconnect it right there, I'd have my carbonyl here. Any questions on that one? All right, for question number 12, using ammonia as your source of nitrogen, show the reagents you would use to prepare each of the following amines. So if you wanted to use reductive amination, you would have to make your ethyl amines here. You can't just use ammonia. So that is going to be one of our caveats. So if we're using ammonia, as our source of nitrogen, we're not given stipulations for carbon. So we can just use that as one source. So I'm going to use ethanal or acetaldehyde plus NaBH3CN. So that's how I use ammonia as my source of nitrogen. And then I can just add that acetaldehyde again and do that same reaction again to get the target molecule. And for E, that's just an extra ethyl group. So we can just do the same synthesis we did for D and just add another acetaldehyde. Questions there? All right, so this one we have cyclohexylamine, and we're going to treat it with methyl iodide. Whoops. Followed by silver oxide. Okay, what would be our product here? All right, good. So we're going to get A for this one. And because there's only one type of proton, we'll just get A. B is not what we're going to get because we've added a carbon there. And then the methyl iodide is going to eliminate the NH2, so we won't get that either. So we should have A there. Questions there? Okay, so this one is what will we get if we retreat NH2 or this methoxyaniline with NaNO2 NHCl. All right, so for this, aniline is a primary amine. So we are actually going to form the N2. So this is that HONO reagent that we use to make N2 in order to react it with another reagent to swap it out easily. The B would only result if the nitrosamine would only result if you had a secondary amine. Questions there? All right, we're looking for synthesis here. Actually, I'm going to copy this onto our slides. We have just the one problem there. Okay, so we need to synthesize a compound using NH2, and we need to add a CN there. So if I'm using my reactions that I just learned, I can add a CN there from an N2, which I can make from NH2. Oops. And so all I need to do to this starting material is to put an isopropyl group on there. And some of you might be thinking I can just do this, right? Do a Friedel-Crafts, but we can't do a Friedel-Crafts with that NH2 on there. So this is not going to work. So we need to deactivate it or make it less electron donating. All right, so we're making it less powerful. And one way to do that is to add an acetate group onto there. So we can use acetic anhydride. And this is in a reaction that we did in chapter 21. If you react an amine with acetic anhydride or an acid anhydride, we get the, whoops, we make an amide. So we're adding this part of the molecule onto that nitrogen. So now with that electron donating, or I'm sorry, electron withdrawing carbonyl on there, this is going to be less electron donating. It's still electron donating, but not as much. And so it's not going to affect the Friedel-Crafts reaction. So now we can go ahead and do the Friedel-Crafts. And then to remove it, we just add water plus acid. And then we have to make that N2 using the, you can just write HONO, but that's the NaNO2 plus HCl. And then to get to here, we use NaCN, or no, CuCN. Questions there? All right, any ideas for this synthesis? All right, so a BR from a CL, we can use the HONO again, which requires the amine. And if you remember a long time ago, we could make an amine from a CL. So in the forward direction, you have chlorobenzene. We react it with NaNH2, liquid ammonia, and this goes through the benzyne intermediate.
Exercise 11 and then 12. And then exercise 8 is 1, 2, 3 pages. Because I was going to say, I do not like.
All right, questions on that? Okay, so this is kind of similar to what we were doing, not synthesis, but we have aniline. And if we treat them with this reagent here, pH is benzene, CH2, and then this is sometimes the shorthand for this. So we're reacting it with an acid chloride. So that's going to react with the acid chloride. To get us that. So we'll make an amide there. And then in aniline, ethanol followed by copper nitrile is going to form the nitrile. Questions there? All right, synthesis of this compound. Why don't you take a minute to come up with a synthesis? And then I'll put one up as well and see if yours works or if ours works. Okay, there's a couple of different ways that you can go about doing this one. But if you were starting with your retrosynthesis, you might have had this as your intermediate before, plus maybe an acid chloride. And that could have come from some amine plus the methyl group via reductive amination. And so there's also different ways to make this amine. So if you're coming off of that one or this, the benzylamine, you could have made it from here. Or this N3. And then if you made it from the amide, you would go through the acid chloride or carboxylic acid. We'll just go with carboxylic acid. And from the azide, you could use just the Br. So there's two different routes, but I would say the end steps, the last two steps are going to be similar there. All right, so if we did one forward synthesis, let's go with the carboxylic acid route. So you can do Friedel-Crafts and just add the methyl group and then KMNO4. What you cannot use for a Friedel-Crafts is this reagent. That one is not going to work very well. So that might be tempting to just try to put all your functional groups on at the same time. But you need to put the methyl group on and then oxidize it. And then we can form the amide. You can use you can either go through the acid chloride, or we can use, DCC and ammonia. And then we're going to reduce with excess LAH. Do our reductive amination. And then the acid chloride to acetylate it. You could also use acetic anhydride there. If you wanted to go through the BR route, the benzyl bromide or benzyl bromide here, you could add the CH3, the same route, but instead you would just take a different diversion and add MBS to brominate there. Then you can use NaN3 followed by H2. That gives you the NH2, and then you can go through the same steps as the rest of that. So that route might be a little bit quicker, but either of those would work. Did anybody have something different that they wanted to share or get checked? Okay, let's look at the next problem here. This is no, this one's just one step. So what would the product be for this particular problem? So we have an amine plus excess methyl iodide and silver oxide. All right, actually, there's a third option here, which would be, so the N is going to get methylated, and it will only get methylated 2 times because it already has 2 bonds. So we're going to add 2 methyl groups here. And then we're going to do an elimination. So you can break on either side because it's going to give us the same thing. So it's only going to do 1 elimination. So we'll get the N with the 2 methyl groups, and then a double bond right there. So the correct answer wasn't up there. We have 1, 2, just do my carbon count, 4, 5. So the 1 N will get the methyl groups, and then we eliminate on the other side. Questions on that one? All right, how about this one, multi-step here? All right, so this one is the Gabriel synthesis. And the nitrogen is going to form an amine with the alkyl halide, so we're going to get C for this one. Questions there? All right, how about this one? This is a multi-stepper. Let's see what you get for this one. Okay, in the first step here, the NaCN is going to attack right there. So we'll get the nitrile. So we've added that carbon from the CN. That's going to get hydrolyzed. This is step 2 to the carboxylic acid, which will form the acid chloride after reagent number 3. And excess NH3 will make the amide. So C is our answer here. Questions there? All right, we've got another one of these. Let's just do this one together. Reagent 1, HNO3 plus H2SO4 is going to make nitrobenzene. That iron and acid is going to reduce it to the amine. So this is for steps 2 and 3. The NaNO2 will make N2. And then copper nitrile will make the cyanobenzene. Any questions there? All right, there's two more problems I'd like for us to do. All right, this one is filling in reagents. So for reagent A, we're going from a carbonyl to a nitrogen, a dimethylamine here. So one thing, this is not an imine, so we want to do a reductive amination. So I can add nitrogen dimethylamine here with NaBH3CN. And then we're doing an elimination to make that double bond. So what you can do is add more methyl iodide or excess of methyl iodide, followed by Ag2O. So that's going to do that Hofmann elimination. And now we have a cyclopentane with 2 aldehyde groups on there. And if you remember from your double bond reactions, if you cleave it, you get 2 aldehydes, and this is the 5-membered ring there. This will become a CHO, and that will become a CHO. So this is just O3 and DMS. And then to make the amines here, we still have this carbon. So we're going to react it with ammonia. This will be excess ammonia with NaBH3CN. Questions on that? And this last one, I think we may have done something similar. We have meta-bromoaniline. So it's treated with NaNO2. And then it's treated with copper bromide. So what is our product going to look like for that one? All right, good. So the Br is going to take the place of the N2. And so we're just going to add a Br here. So C is our correct answer on that one. All right, so we're going to stop there. There's a couple of synthesis problems that I have left for this chapter, so we'll save those for tomorrow, just to let you guys get your bearings a little bit with the amines. And then I'll throw on some of those extra problems, or the bonus problems that we have listed on the Moodle website. I think it's under either the lecture videos or it's in the problem set problems. So if you have questions, I'll hang around for that afterwards. Otherwise, I will see you tomorrow.